how you can insert the ACI in Fabric into your existing data center network design. A couple of topics I want to highlight is the scale out, how you go about this, what's the reason you actually consider adding something, what are the L2, L3 DCI options you have, as well as the segmentation, how is it different, how you would design today and how you can design actually with an ACI Fabric, and actually how it's not that different. But anyway, let me start with number one. So typical network design, if you look at this, and I have it here, if this is an existing part and you have, let's say, a Cisco product, which I hope, you have Nexus 2000, 7000, you have your leaf and the racks, every top of rack for a rack here, and then you have your aggregation spine switches, and you have them connected either layer 2, 3 boundary up here, or you have your layer 2, 3 boundary up here. It doesn't really matter, any one of these designs, and then you have your service. So typically what you do today there, you have an element manager or you have DCNM, like a fabric manager, managing this network, and then you have some kind of an orchestration tool on top. That could be, I don't know, IBM Tivoli, HP, could be BMC, Cisco's UCS Direct. There are whole different options, or even OpenStack would be an option, what you can use here, right? And so the question then becomes, how do I insert ACI? Because ACI is clearly you have a controller, and how does this fit in, right? And the answer to this one is, typically what we see, what customers will do, they having this design, they're running out of rack space because the servers are getting filled up, and they need to add a new rack. So the question now becomes, do I just add another top of rack switch and connecting in here? Or if I start, let's say I need 2 more racks, I'm going to put 2 top of rack switches here, which would be a Nexus 9300. I put a little spine there. You could start either as fixed or with a modular spine, depending how big you want to build that part. And then you put the APIC controller, the application policy, and as small as 2 racks. Right? I'm not talking about you need to replace anything. You just literally scale out and add additional 2 racks, 4 racks, whatever you need. You put that in, you put your controller. And now in terms of integration, which is what you have today, which is the orchestration, instead of talking to an element manager, DCNM, you're basically talking to a controller, the APIC controller. So that's kind of on a high level how this insertion will work, and what we see customers are doing. Literally the trigger point is, as I said, you're running out of space, you need to add racks, or what you want to do, you have a new application, you need some dedicated racks because that's how you design in your enterprise, you put them up anyway, and so then you use this as a point where you use the APIC controller and to build this out. The other question that always comes is, okay, I have stuff sitting here and it needs to talk to whatever I put in this pod, right? Can I do this? And the answer is, of course, right? You have either layer 2, as I said here on the boundary, or layer 3. And you can have a layer 2, layer 3 connection, standard VLAN, subnets, a routing from here to that fabric. There's no issue. That's easy designs. And then I put your DCI. Obviously, if you're in a scenario where this pod sits in one data center and that pod sits in a different data center, you probably have some kind of a DCI solution in the middle, which could be a Nexus 7000 running OTV, or MPLS, VPLS, or it could be an ASR 1000 or 9000 from Cisco running the same. The same applies here. It doesn't really matter if that's an ACI pod and this is a standard pod. You're going to do the same thing in the middle. You're going to have a Nexus 7000 pair sitting here, connecting to here, or an ASR router. No real difference. So the question really, and I hope it becomes clearer, is how do you insert an APIC-controlled environment? You basically start with as few as 2 racks and basically build a little pod that is APIC-controlled, and then you grow that out over time as you would have done here. So no real difference. So that's the boxes and how they connect and what the connectivity is. There's a second piece I want to touch to, and this is the segmentation, because that's the other question always comes. Here I design around VLANs and VRFs when I want to do segmentation or isolation. That's not quite here from all I have read. You know, you guys, Cisco, talking about EPGs and profiles. How do I get from here to here? So now let me talk a little bit about that topic. Same thing here. I say this is the existing part with the Nexus 2000, 7000, 2, 3, 5, 6, 7. And here in this, the grow out rack, the ACI fabric, you basically can use a Nexus 9300 as a leaf and Nexus 9500 as a spine. And you still can use, by the way, your Nexus 2000. You can use them actually as well. So the question, as I say, is becoming, how do you go from segmentation, isolation, grouping you have on the existing part, how does it map to whatever you're going to do on the ACI side? It's actually very straightforward. You typically have either VLANs to segment stuff out, and then if you want to talk between things in the same VLAN to the next one, you route between the VLANs. You might have different route domains, typically use verbs for different tenants, or you have a concept of zones. Most enterprises I have seen have probably 3 to 4 zones in their data center defined, which is like the production zone for all the apps, the DMZ zone, and then they have a shared services zone, and then maybe they have have a special zone for certain highly critical applications. The point being, whatever that grouping is you use here, and it's really not on a per application basis, right? You can make this very coarse or very fine grained. That maps literally either one of them. You can use the same method on the other side, which is the concept of network profiles and EPGs. Whatever your grouping is here, let's say your grouping was a VLAN, you map a VLAN into an EPG, which is a grouping of endpoints as well. If you here were grouping around VRFs, you can use the VRFs grouping and use the same grouping for EPGs. If you use the zone grouping, you basically use EPGs to map zones into a grouping function. And then you have your network profile, which basically defines which EPG can talk with which other EPG. Same what you would here do. We basically have big firewalls and say between VLANs I can talk here, between VRF I use a firewall I can talk here, or between zones. That literally maps one-to-one into network profiles and EPGs. So the main point really is whatever segmentation methodology you're applying here, you can map those very straightforward in the same very flexible way on the other side, which is the concept of EPG endpoint groups, and then profiles that define connectivity between those. So I hope that gives you a little bit better sense on how easy it is actually to move from how you structure and organize your network, in a sense, from the current world into the approach with the API controller. And as you might imagine, the whole beauty of this is, instead of actually managing these profiles on a box-by-box level on this side, here you actually have a central control point with the API controller that gives you the right abstraction layer in terms of managing profiles and EPGs to make it much more easier from a day one, as well as actually from a day two operational perspective. With that said, again, thanks for the time, thanks for listening, and for more information, please go to the bottom, to the URL on the bottom of the screen. Thank you.